Hi, Julian from PopcornFX here. In this video we're going to dive into the vector field viewer that came in PopcornFX 2.6. So vector fields in PopcornFX are FGA files, which is a format that you can export from Houdini, Maya, VectorAgen, and possibly other tools. It's also the format that Unreal Engine uses natively for its vector fields. So before 2.6, when you double-clicked on an FGA files, you just had an error message. Now it will instead open the vector field viewer. So we'll do a quick review of the different panels. Then I'll show you how to inspect the vector field, what you can change on the bake settings and what it changes. The import-export feature, some details on hot reloading and error message displays, and finally the performance slash benchmark mode, which allows you to preview runtime performance. So first, the different panels. The most obvious one is the viewport, the 3D viewport. It has the same controls as the effect editor 3D viewport. So you hold Alt and you click the view to orbit, left click. You right click to dolly and shift right click to dolly faster. Next we have the asset details panel, which shows different information about the vector field, and when you inspect it, different information about the current voxel you're inspecting. We'll see that in a minute. Next is the bake settings panel, where you control how the vector field should be imported, baked for runtime use by the simulation. And last panel is the timeline panel, which is used for animated vector fields. So this current vector field here doesn't have any animation, so the timeline panel only shows a single keyframe and is basically useless for this vector field. We'll open an animated vector field afterwards so you can see how to use that. So here we have a path visualization where the vector field actually is displayed using curved paths that show how the particles would move along the vector field along those paths. So here in the details panel I have a path length slider that I can use to shorten or make the paths longer. You also have another mode, which is the vector mode, and as this vector field is pretty high resolution here, it's a 64 x 64 x 64 vector field, that view is pretty much unreadable. So similarly to the path lengths, you have the vector scale slider that allows you to change the size of the vectors for the visualization only. And to actually use that mode for high resolution vector fields, you will need to use the slicing view. So here we pick an axis, for example the z-axis, and it will display a slice of the vector field along that axis. Here I can change the position of the slice, same thing here, and changing the length of the vectors allow you to quickly view the actual vectors. It also works obviously for the path mode, where you can see the actual paths. And when viewing vector fields, I find it a lot easier to view them with a slice than with the whole vector field. So when I hover the slice, you can see that I also have a path preview that shows me for a particle that would be spawned under my mouse cursor where it's going to go. So if I click, I can pick that particular place and keep it, and if I control click, I can pick multiple places. So if you zoom in there, you will see some ticks along those paths, and each of those ticks is is 1 second, basically. So if a particle follows that path with infinite drag or full tightness, as it is called in some tools, it will reach that point after 1 second, and that point after an additional second, etc. So it kind of gives you an idea of how the particle accelerates or slows down across the vector field. So here, for example, I know there is a place where, so here, where the particles change direction, down there, you can see that the color is also based on the speed of the particles. So in that spot, the particle will actually slow down a lot compared to other places. If you click outside, it just deselects your entire selection. So you have this path view also when you're in vector mode. So this is pretty useful to get a better understanding of how the particles move around the vector field. And when you select something, you will note in that panel here that it will display the actual information of the point you picked, and those numbers above it are the coordinates of the hovered point. So here you have the IDs of the current voxel, the normalized UVW coordinates, the actual position you would need to inject inside a sampling node to sample the vector field at that specific location. So this can be useful if you're building a particle behavior and you want to spawn the particles at a specific place in the vector field to inject them in the vector field. Here, just find the place you're interested in the vector field viewer and look at what position it is and initialize your particles to this position, and they will spawn here. And you also have the actual vector in the vector field at that place and the length of that vector. So now let's open an animated vector field. So when you open an animated vector field, you will see that the timeline has now multiple keyframes. The time range is highlighted in green. So quick word about the timeline controls. You have to press the middle mouse button to move the view, just like the timeline in the effect editor. You can use the mouse wheel to zoom in and out, and you have a couple shortcuts. So Shift E will reset the zoom, and Control E will fit all the keyframes in the view. If you click anywhere in the timeline, it pauses the animation and you can seek to whatever point you want to inspect. So here I'm going to go back to slicing view just because everything is clearer in my opinion. So let's say I pick this point, and if I scrub the timeline, you will see the selected path being updated at this particular frame in the animation. So with animated vector field, you have some more controls. Especially you can preview the filter mode here. So by default, the vector field viewer will display the vector field in quadrilinear mode. So this means that it interpolates across keyframes along the time axis. Trilinear means it interpolates across the 3D coordinates of the voxels. So we have smoothly varying vectors when we move from one voxel to the other. And point disables any interpolation. It just picks the closest voxel and returns that vector, which makes for very jaggy paths, as you can see here. As I move around the vector field, the paths just jump around erratically. This is just because as the particle moves along a path, it will, you can kind of see it here, it will only pick a new vector when the path crosses a voxel boundary, so it makes for very chaotic end positions, as a very small change in position in the original voxel will diverge very quickly along the path. So the only point of using the point, no pun intended, interpolation is to actually get a faster sampling. So we'll see that at the end of the video with the benchmark mode. So you should at least use trilinear, and ideal is quadrilinear, but it's also a bit slower. So of course, when you don't have an animated vector field, quadrilinear and trilinear do the same thing because there are no frames to interpolate between, so they have the same performance. Well, if you pick quadrilinear, it actually falls back to trilinear. So, a quick word about something that can be seen as a small detail. It's the start and end of the vector field. If you sample it and wrap the time cursor, so for example here, when I go at the end, when I go past the end, here it will go back to the beginning, so we have a looping animation. But you will notice that if I go past the half of the keyframe, of the last keyframe, the animation stops. So it's smooth between keyframes up until half of the last one, and then it stops. And same thing when I go back to the first keyframe here, it doesn't animate until it goes past the half of the first keyframe. So this is because I am clamping the time coordinate in the wrap mode here. Quick word about the way it is displayed here in the timeline. This is the 2.6.0 display, and it's very likely we are going to improve that display by showing the range of a keyframe and moving the keyframe to the middle of the range and not the beginning of the range as it is currently when you are in quadrilinear mode, because this would make it much more obvious when the full interpolation of a single keyframe is, which is pretty unintuitive right now. So if you want to have a smooth interpolation between start and end, you will need to set that to wrap. And here, as you will see, the vectors will smoothly interpolate between the first and the last frame. So in the case of this vector field, it makes for a pretty weird interpolation, a pretty weird animation, because the start and end frames aren't made to seamlessly loop. But you get the idea. So before wrapping up this video, I'm going to quickly show you in the effect editor how you can control those wrap and filter settings. So here I'm going to open this tutorials effect, which uses the vector field we just saw. So I'll open the animated VF layer, which is the layer controlling the behavior of the particles that follow the vector field. So here I have the render node, the physics node, a bunch of other nodes, and here the animated vector field node, which is a turbulence node, vector field node. And here I can see in the vector field resource property the path to my FGA file. So we don't display any thumbnail currently for the FGA files, so that's why you have the empty thumbnail here. But you can right click on this and choose Open Asset, and it will open the vector field viewer for that specific vector field. So that can be handy. underneath that, you will see the wrap settings and the filtering settings. So that's where you pick quadrilinear, trilinear, point, or where you specify if you want to wrap the time coordinate or not. And here, if I uncheck wrap time, you will see that it stops completely the animation. So this is because we sample the vector field with scene time, so I need to reset the scene to see the animation, and it will just stop whenever the scene time here exceeds the end of the animation. So the animation cursor, the time cursor, is actually between 0 and 1, but here we multiply scene time by 0.2, so it actually divides it by 5, so it will take 5 seconds to reach the end of the animation. Here at 5 seconds, I'm at the last frame already. So I'll just restore the wrap time, and you can see in here that the particles are ejected outside the vector field, which doesn't really match the paths we were seeing in the vector field viewer. And that's simply because we are wrapping the coordinates instead of clamping them. So as soon as some particles go out of the vector field, they sample a similar vector field next to it. You can basically see that as this vector field being tiled infinitely across the space. So if I uncheck all that, now the sampling coordinates are clamped, and there is this single vector field in the center, and all its borders duplicate the border vectors indefinitely on each side. It's pretty similar to how texture sampling works, whether you are in repeat or clamp mode. So this is actually much more visible with the roto wash effect. I should have shown that one instead. So here, if I reduce the global scale of the vector field, here it's not wrapping, so you can kind of see the vortex in the center and the vectors that extend outside the bounds of the actual vector field. And if I set it to wrap on all axes, here you can clearly visualize the tiling of the vector field. And let's say I don't want to tile it vertically, I just disable the wrap vertical, and it will still wrap horizontally but not vertically. So that's it for this video. We'll see the bake settings, import export dialogues, and benchmark mode in the upcoming videos. Thanks for watching.